So welcome all to the 16th in a row of the Amplifying Voices webinar series. My name is Mina Bezic, and I'm the ASLO's Early Career Committee Chair. Amplifying Voices webinar series has been held since November 2021, and it was organized by Early Career Committee. We are 12 members, 12 early career scientists in aquatic sciences. And we aim with this webinar to promote the exciting work of early career aquatic scientists from underrepresented groups in our global community. During this session, 2 early career speakers each give a 20 minutes presentation of their work, and this is followed by questions and answers discussion. You can always view the previous Amplifying Voices talks on YouTube channel of ASLO. If you're interested in giving a presentation as part of the ASLO Amplifying Voices series, please then follow this link or QR code to view and fill out our application, and then we will evaluate your application. Okay, let me just switch slides. So today we have 2 speakers, Changjiang and Ana Vasquez. And Qing is a PhD student in aquatic ecology. He's in his last year of PhD. He's based at the Netherlands Institute of Ecology, and Qing is originally from China. He works on lake restoration, climate change impacts, ecological modeling, and today he will be presenting one chapter of his PhD thesis. And I would like to invite Qing to share his screen the moment I unshare mine. Yes, please, the floor of the Zoom is yours.
Great. Thank you, Mina, for your introduction. I assume that my PowerPoint is now shown. If not, let me know. Okay. Hello, everyone. Okay, great. Hello, everyone. As Mina introduced, my name is Changjiang. I'm from China originally, and currently I'm doing my PhD in the Netherlands in my last year. And today I would be introducing one of my chapter. Before I start, I want to apologize for my English, and please forgive me if you have difficulty in understanding me. I will try to speak slowly and clearly. All right, so let's start. The title of this work is called Modeling the Response of Aquatic Ecosystem Services to Restoration Measures under Different Climate Scenarios. So first, some introduction of the problems we want to address in this study. As we know that lakes, like many other ecosystems, provide us a lot of valuable services like swimming, fishing, irrigation, bird watching surrounding the lakes, habitat, and also nutrient retention, and many others. Like also other ecosystems, the demanding of almost all the services is currently increasing, as shown by the study by Carpenter et al. In the upper panel is the human use of different services. They are all showing, almost all are showing an increased trend. On the other side is the conditions for these ecosystems to provide us services, and they are, however, decreasing in many cases. This is true also for our aquatic ecosystems, as shown by one of the paper from Ecology et al. So we can say that our aquatic ecosystem is now having problem in providing services to human beings because they are exposed to too many pressures. And this problem is further aggregated by climate change as a paper by Moss et al. They are basically suggesting that climate change and eutrophication are often reinforcing their symptoms. So therefore, we do have an urgent or dire need for restoring our lakes so that they can keep providing the services we are needing from them. And in our group, we did some experiments to test how climate change affect the effectiveness of different restoration measures, and the results suggesting that their effectiveness do get hampered under climate change. But it remains still not explored is how these measures are affected when under climate change, and regarding their impact on restoring our ecosystem services. For answering this question, we developed a modeling framework that enable us to evaluate the effects of different measures on ecosystem services under the pressure by climate change. And the graph on the right side is explaining the workflow we did. So restoration by having impacts on our ecosystem states, we expect it can lead to a change in their suitability for providing ecosystem services. A bit further explanation of what we exactly did. First, we covered a lake physics model, F-lake, and people from IGB should might heard about it already, to an ecosystem lake called PC Lake Plus, so that we are able to simulate how ecosystem state varies over time in response to different environment conditions, including different climate conditions, and also regarding to different nutrient loading. And having first maybe a little bit more introduction of this ecosystem model we used in our study, is an ecosystem model that explicitly model the ecological processes in the lake, in the water, within the framework of nitrogen and with the framework of nutrient cycles. And it also includes a simple food web, and it enables us to simulate a variety of different ecosystem state indicators. So continue with the workflow. After having the ability to model the change in ecosystem state indicators, we can then try to translate it into the ecosystem services. How we did that, we used a approach that is a threshold-based approach developed by Zhan et al. They, by determining the different thresholds for the corresponding services, they can quantitatively describe the suitability for providing different services in relation to the ecosystem states. I use the swimming as an example to explain what this method exactly do. So for swimming, it's determined by both water transparency, so indicated by the sec depth, as well as the cyanobacterial chlorophyll concentration. For suitable water for providing service, for providing swimming service, it has a good sec depth. So when we set a threshold, when the water transparency has a sec depth above this threshold, we say the suitability reach 1, meaning perfect suitability. Below that threshold of safety depth, the suitability will decline. And the same principle applied to cyanobacteria chlorophyll concentration, only in opposite relationship. So we also determined we have a threshold saying when our water has a cyanobacteria chlorophyll concentration above that threshold, then this water is no longer suitable for swimming because it has a health risk. And below that threshold, then the suitability will range between 0 and 1. And the threshold values determined in this paper are based on literature review, expert knowledge, and also the monitoring campaign carried out in south of the Netherlands for like many quarry lakes, like the one we are going to apply our method. And we, using this framework we developed, we did different scenarios, both on different restoration measures as well as on different climate scenarios. So for restoration measures, we simulated two different types of measures. One is the technology-based measure. So more specifically, we simulated how nutrient intervention, so how by reducing nutrient loading will affect our ecosystems and therefore their ability for providing services. And on the right side is a nature-based solution. So we simulate how by implementing different magnitude of wetland construction, how that will affect the system from providing services. A Peace Lake, the ecosystem model I introduced in previous slides, has a wetland module that enables us to simulate the change, how the change in wetland coverage lead to different response in the lake water column. All right. And for climate scenarios, we simulate both the current climate condition as well as the predicted 2050 climate scenario in the Netherlands by Royal Netherlands Meteorological Institute. Basically, we simulate, we input the data with the simulated climate data suggested by them. And then we applied this model to a real-world lake. It's a man-made lake created by sound abstraction for construction use. So it's isolated from surrounding surface water. It's mainly fed by groundwater and precipitation. It's polluted by nutrients due to the fertilizer application in the surrounding agriculture area, but is also being used for many services by the local for the local residents. First, we after applying this model, we first have a look of how this model generally perform in capturing ecosystem states in these lakes. So the left upper panel is the results by F Lake, is suggesting a prolonged stratification period on the future condition by roughly 2 to 3 weeks. And the results from Peace Lake, the ecosystem model, is suggesting is like for instance, the orange dots is our monitored water quality in the epidemium. We observed a drop during the stratification period, and the Peace Lake is suggesting is caused or mainly attributed to the surface bloom. So the surface cyanobacteria bloom. The Peace Lake has a separate cyanobacteria bloom that is capable of modeling the vertical migration of cyanobacteria from epineumium towards the surface. So it's suggesting during stratification we have more cyanobacteria migrating from water column into surface, forming a bloom there. All right, so after have validated the performance, we then carry out the scenario as introduced in previous slides. So let's first look at the results on how by different restoration measures our lake ecosystem states respond. So the yellow, the orange corner represent phosphorus reduction, ranging from 0, meaning no phosphorus reduction at all. So the lake stay as the initial loading condition, and all the way to 100, meaning all the phosphorus loading into the lake was removed. And then the green color represent the wetland construction. So for instance, like 10% in the beginning is the initial wetland coverage relative to the lake area. So the wetland area is 10% of the lake water, and we simulate all the way to 80%. And the dashed lines then represent the results under future 2050 climate conditions. So we some summarize of what those results mean. So first, we can see that both these two measures showed eutrophication control effects with increased oxygen conditions and increased water transparency indicated by Secchi depths, and decreased phytoplankton, like here shown by surface cyanobacteria chlorophyll, as well as the improved light condition. So critical depth for macrophyte here is a parameter that indicated the depth at which the macrophyte can still establish. When the depth exists that threshold, the light is not sufficient for macrophyte establishment anymore. However, regarding the climate effects, we see apparent negative impacts. It with both decreased oxygen conditions, decreased transparency, and increased algae biomass, and decreased light conditions. Well, what does this mean to our ecosystem services? Then having this ecosystem service module in our framework, we can translate the change in ecosystem state indicators into the change in our ecosystem service provisioning. We modeled 9 different services that can be provided by quarry lake, like the one we simulate. So they are fishing, so the reef for roof thatching, irrigation, nutrient retention, macrophyte habitat, and capture of particles swimming, and also the marsh tone in the lake can also be beneficial for bird watching. All right, so how the results are suggesting. First, most of the services did show an increase, except for fishing and bird watching. This is agreeing with our agreement, because for service like fishing and bird watching, they are normally requiring a more productive systems that has higher fish biomass, so more bird visiting. So with oligotrophication of our lake, these services, their suitability will be decreased. But for other, like nutrient retention, macrophyte habitat, or swimming, they showed increase. And another interesting result or point we can summarize is almost all of these services, their response to our restoration measures is nonlinear. Is suggesting a threshold relationship using, for instance, phosphorus as a retention. If by applying phosphorus reduction, it is suggesting that the effectiveness of this measure is only start to be significant upon reaching a certain magnitude of phosphorus reduction. And the opposite relationship is shown for wetland, that upon reaching a certain magnitude of wetland construction, the effects of this restoration will decline. And what does climate change do? So if we use microphyte habitat as example to acquire the same level of service provisioning, so this 0 to 1 represent the suitability for providing these services. To acquire the same level of these services under future climate, so the dashed line, we is suggesting that we need more intensified restoration efforts. So we need more phosphorus reduction or more wetland construction in order to reach the same level of service provisioning. Yeah, great. So this, so what we can summarize or conclude from this study, some take-home messages here is first, our restoration measures, at least the two we simulated, do show an impact on improving ecosystem services that we modeled, except for the services that require more productive systems, like fishing and bird watching. And the second interesting message to take home is the impacts of our restoration measures are nonlinear, and we shouldn't in restoration application we shouldn't expect a linear response from our system to what we did. So either we should expect that we need to reach a threshold in order to have the results visible, or we should expect a decline of our effectiveness. And the last but not least is, under future climate scenario, we might need more intensified restoration efforts to protect our ecosystem for providing us services we need. All right, with that, I want to thank you for your attention. Yeah, and also thank you for ASLO, this webinar, for giving us the chance to present our work, and also with acknowledgement of my co-authors who gave contribution in this study, Sven Teunig, microlearning, Lisette Pompotomis, as well as the founder that found me doing this project, Drying River Network and Aqua. All right, with that, I stop sharing, I think.
Qing, thank you very much for this excellent talk. You're also getting digital applause from our audience. And thank you very much. This is a really important topic. And I would like to invite the audience to ask questions, if anyone.
Hi, I have a question. Hi, Qing.
Hello,
Carolina.
Yes,
hello,
good to
Carolina.
see you.
Hello.
Great presentation. My question is regarding how many lakes did you apply this modeling approach?
So far, we started with one, that we have already some monitoring data there, and also that lake is used in this some monitoring campaign for determining those threshold values. We thought start with this one, and then our method is more applicable, and we have more knowledge on it.
That's great. And is this lake located in Netherlands?
Yeah, in south of the Netherlands. Yeah, so it's quite the surrounding area is quite agriculture dominant, but also this is used by local residents for swimming, for fishing. Yeah.
Great. So have you decided this specific like ecosystem service that you evaluated based on all the land use and the watershed, this specific watershed, right?
And the service we modeled is we decided based on previous research that identified all the services that quarry lakes. The quarry lake is defined as sound abstraction lake that created by human for different purposes, and they are normally isolated from surrounding area, and they provide sometimes more lower services to us, and the services we modeled is based on both what this kind of system can provide, as well as what the model can model, because although PCLake can already model quite many ecosystem state indicators, but it still has its limitation. So there's two constraints for decision.
Great. Yeah, it's a great work, and I look forward to see this modeling approach applied for like different lakes in different regions, to see what results we could expect based on like different locations and other factors. So great.
Yeah.
Thank you.
Thank you.
Danny, would you like to ask the question?
Yeah, thanks. So it might be a very stupid and naive question because I'm not a modeler and not into ecosystem restoration. But when you talk about restoration of ecosystem, do you aim at some pre-industrial era environment, or do you aim to drive the system to make it more agreeable to human use? So you mentioned fishing, swimming, and related to that, maybe a part B of the same question, can it be the different ecosystem services or human services that you model have negative interactions one with another? So for example, swimming in a shallow lake and resuspension of sediments versus nutrient retention. How does it work together?
Yeah, thank you, Danny, for your question. No question can be stupid, only answer can be stupid. So I will try to not answer stupidly. First, to be the introduction of like when we study ecosystem services, is of course from the standing point of human, what we need from a system, and then our target of restoring the system is towards to a system that are more suitable for providing the services that we are requiring from them, which is not always necessarily good for the system themselves, if from their standing point of view. And our study is also kind of based on the previous literature suggesting that lake, by shifting their state, like for general lakes, there are alternative states, shifting from eutrophic, so phytoplankton dominant states, to macrophyte dominant states. They are providing different type of services. So our study is kind of based on that, so that we say by controlling eutrophication level of the lake, we might affect the system in terms of their suitability for providing different services. And regarding your question on the potential competing requirement of different services, definitely true. Like currently in this framework is already showing that, for instance, for the services that require more oligotrophic system is in a conflict with the system, with the services that require more better water quality or more productive system. So, and then there are also other like the one you mentioned, swimming, by promoting these services by having more like swimming, you might affect the states by suspension. Those feedbacks is, however, currently not captured in our model yet. So it's currently still one-way translation without the feedback from what those service provisioning mean back to our system. That's something to further develop. Yeah, but thank you for points.
Thanks.
Okay.
Thank you, Qing. Hans-Peter, please.
I have a quick question concerning your overall project. So how do extreme events impact your lake behavior, and how does it impact the ecosystems? I mean, phosphorus can be released by water input. So if you have a flooding event, and you may also have sedimentary suspension, which brings in phosphorus. Do you account for this? Or trying, maybe, you know?
Thank you, Hans-Peter. Yeah, like the effects of extreme climate events, which also in this study, unfortunately, we didn't account for that. Or whether we can't account or not is actually unknown, because we input the model with no monitored climate data. Then if saying climate data has increased precipitation, what does that mean to our lake? Would be to some extent definitely not the most or definitely not the comprehensive capture, but it can capture at least the change in climate condition. However, how that affect our lake, for instance, how that affect nutrient loading change, that part is not captured, because for this lake we established the nutrient loading on one go after measuring all the potential sources. It's really not so easy to have a dynamic of the nutrient balance. And we also kind of using one of the reasons using this lake is relatively isolated, mostly fed by groundwater, which is relatively more stable compared to lake more regulated by surround surface big inflow. But we kind of did in our group some kind of modeling on the effects of extreme climate events. Is a bit tricky and difficult. It really depends how you set up the change of nutrient loading and during the extreme events. Yeah, so for using modeling as an approach, I would say at this moment is still challenging. But we did some our previous study are based on experiments that do show very at least in laboratory or in a mesocosm outside of outside in the aquatic ecosystem, it do show the impacts from heat wave or precipitation by changing even by changing the mixing region of phytoplankton, like doing a strong runoff, or the heat wave by affecting the cycle, a nutrient cycle has an effect on the all ecosystem states. Yeah.
Okay. Yeah, you cannot account for everything. I know.
Yeah. Thank you.
Qing, thank you very much, and for this nice discussion, and to all who had questions. We can now go to our second speaker, who is Ana Vasquez, and she is originally from Costa Rica, but she is now a doctoral candidate in marine sciences at Tongji University in Shanghai. This is a state key laboratory of marine geology, MG Lab in Shanghai, China. So Anna, please share your screen, and the Zoom floor is yours.
Okay, thank you. Good day, everyone. So my research is focused on the Kuiper isotope signatures in the Changjiang River, also known as the Yangtze River, most popularly. Changjiang is the third largest river in the world, and recent previous studies found out that the copper isotope in the Changjiang was initially heavy. So they consider this to be related mostly to anthropic pollution. However, there was not a real, well, there was only suggestions, there was no real evidence. So my PhD focuses on to verify what are those controlling factors for these initially heavy signatures. So in the case of the rivers, the dissolved and the suspended particulate matter are the major carriers of trace elements or transitional metals. So, and these trace elements provide understanding in the significance between, well, in the interactions between the solids, the solid surfaces, and eventually how the different elements cycling happens from source to sink. And what is the real, or it can be defined, what is the mass balance of each element, or at least for trace elements in the ocean. So the geological setting is the Changjiang River Basin. So this basin is mostly controlled by the monsoon climate. It extends for around 6,400 kilometers. The catchment area is 1.8 million square kilometers. And for previous research, there is a difference between the Changjiang and the source rivers. So the Changjiang, or the source, starts on the Tibetan Plateau until the estuary, and these headwaters are the rivers, the Tuotuo River, the Tongji River, and the Changjiang. But however, the Yangtze, it's mostly considered to start in the upper reaches, that it's in Chongqing area. So, and it ignores like all the headwaters area. For this research, we try to do the analysis in this side of the river basin that is not being so much analyzed before. So the Changjiang River, so far, the annual flux of the total dissolved solids is between 15 and 20% of anthropological input. And this anthropological input could be referred to certain level of contamination or land cover, or changes in the land cover, or it also can be referred to atmospheric deposition. So the headwater and upper reaches have the highest elevation that can go to over 4,000 over the sea level, and it's mainly composed of sedimentary rocks of marine carbonates, while the middle lower reaches, it's metamorphonic and plutonic rocks. But this area, it also has like a huge concentration of copper ores, of metal ores. So the middle lower reaches is mostly plain areas. So our analysis, or our research, focused on 33 different locations from the Tongji River until the estuary to do the different spatial analysis for copper major ions, and it not only focused on the dissolved load, but also the particulate load. So the method we use, this analysis was done during 1 month in May. We did this analysis here in Tongji laboratory, and we use this method of chromatography anion exchange with HCl to collect copper and repeat it to be sure that the copper was completely purified for our analysis. So the results we got is there is a heterogeneity between the copper isotopes and the copper concentration in the dissolved load, while the copper in the particulate evidences heavier concentrations. So most of the copper can be found in the particulate stage. This homogeneity in the particulate load shows values that are very similar. And in the case of the isotope, you can see there is not much variation. But in the case of the dissolved copper, there is a large variation, and this is also affected because of the organic complexation. So one of the main questions was if these initially heavy signatures in the Xinjiang was due to natural factors or human activities. So the chemical weathering in the Changjiang River, for the case of the total dissolved solids, you can see there is a huge concentration, especially in the upper side of the river, in the headwaters. And this implies that from the Tongji River, from the Tuotuo River, there is the double concentration of total dissolved solids that you can find in the downstream or even the stream. So the Poyang Lake shows the lower values of all the samples. The CIA means the chemical index of alteration. The average is 71.2, where the upper reaches also shows values that are very low, and the Poyang Lake shows the highest values. This also can be related to certain depletions of certain elements related to the upper continental crust that can be found in different areas, especially in the upper and headwaters in relation to the Poyang Lake. So this also shows that there is a variation in the lithology that influence the chemical weathering input and the variation in the precipitation, that it's not so high in the headwater region, that it's high, especially during the rainy season and the middle lower reaches. So this variation in the lithology, it also varies with the dilution effects of the carbonates in the upper reaches. Could be during discharge, temperature, or even the changes in runoff and land use. So the evidence from the samples are the chemical index of alteration. All the samples, or most of the samples, are shows intermediate silicate weathering. The CI increases downstream, and the TDS reduces in a big amount downstream. And there is a relatively comparison between the aluminium calcium and copper calcium that shows that there is not so much of anthropogenic input where it was initially thought. So the major ions and the weathering shows that there is a big amount of carbonates in the upper reaches and silicate weathering in the lower reaches. There is a big presence of silicates, but also evaporites, especially in the headwaters. The tributaries shows a rapid carbonate weathering that actually after each of the tributaries, you can see a variation with the dissolution and input of this new water or these new rivers into the mainstream. Especially Yibing, that is in the upper reaches, the deviation between the Changjiang and the upper reaches. It can be found a rich or enrichment of the rare earth elements in comparison with mainstream. So the lakes shows metamorphic carbonate silicates. And if you can see the picture, these are the particulates that we collected, and it shows different colors. So the lighter colors are from the headwaters and has the lowest amount of organics. And the darkest are the ones that we collect in middle lower reaches, and they show the biggest concentration of organics. So the lakes also show that the freshwater input into the river alters the concentration of certain elements and major ions, and it shows that in the particulates that the calcification and the changes in the land cover also alterates the concentration of certain elements and ions in the samples. So for the middle lower ridges, the sulfide weathering and period oxidation, it's evidenced. The sediment flow has a disturbance that it's the Three Gorges Dam, the biggest hydrological dam in the world. And before the dam, there was not much evidence of which was the real flow of the river, because even the Changjiang, within the basin, has around 50,000 different dams. And each dam alters the fluctuation of the particulates and the TDS. So within the Three Gorges Dam, the concentration of the particulates, or because of the movement of the water changes, the copper can be found to be lightest, mostly because in these moments, well, in those particular areas, you see that there is a biggest organic complexation that obtains the lightest and makes the copper to convert into heavier. So in the highest, well, in the headwaters, you can find the highest pH, the anion concentration, the highest TDS, and electric conductivity or salinity. And this is an area that is a Tibet plateau. It's an area that it's mostly uninhabited. So a lot of the influence that happens in the mainstream, it's affected by the lithology in this area. So it's not so related to pollution. And especially the Tutu River, the sediment concentration, it's way higher than almost any river in the world. And the same samples, it shows that they have a strong carbonate and evaporate weathering. So for the particulates, like I mentioned before, this shows homogeneity, not only the copper concentration, but also the copper isotopes. And the correlations to be fast, the higher copper concentration shows the lightest copper values. There is a correlation between the magnesium and the copper, that the highest the magnesium, the lowest the copper in relation to calcium. There is a positive correlation between copper calcium and the copper isotopes. And in the case of the TOC, that is a total organic concentration, you see, like, from the headwaters to the estuary, the amount increases, and it's very binded to the particulate stage. So the copper values increase, but mostly in the copper concentration, you can see that they are almost the same results. For the case of the behavior of the river, the upstream, that is the headwaters, shows that there is a high increase that trends to decrease during the upper reaches and then increases again in the middle lower reaches because of the period oxidation and the sulfide weathering. In the case of the enrichment factor, it's found that the mean value of the river is 1.8. That is very much reduced in comparison with other rivers around the world. So this implies that the river is not so polluted as it was thought. So this mainly refers to rock weathering, but in the case near the Poyang Lake and Dongting Lake, there is evidence also the enrichment factor is higher because there is a correlation between not only the period oxidation, but also with some probably increase in problems of water treatment. So it should be eventually shown with temporal invisible research if these samples are affected because of the enrichment, but it should be like something related to seasonal. So in general, the heavy copper is because of fractionation stored by organic rich particles. For dissolved load, we can see that dissolved load is very different. There is a big difference between the different values alongside the river, and there is a fluctuation between increasing and decreasing. So something similar to the particulate is that there is a decrease from the headwaters to the upper reaches, and then an increase from the upper reaches to the middle reaches. So there is a correlation between the pH and the TDS that are reduced, while the dissolved copper is just increased downstream. And there is variations. This is for another research that we are doing now, that is the temporal analysis. So there's variations in time, location, and there is also relation to the oscillation and discharge that alters and varies the concentration of copper in the river. And the dissolved load, it's not so correlated with the TOC, but there is also an increase with there is an increase downstream. So in this conclusion is the dissolved copper, it's influenced by water discharge, the cumulative contribution of the tributaries, the precipitation, deposition, and land degradation. In the case of the tributaries is that after each tributary, the variations in mainstream can increase or decrease, but it eventually gets dissolved in the mainstream. But when we collected the sample before and after the tributary, we see like a big difference between one of the two samples. So in conclusions, the high variability in the copper signatures and the initially heavy copper, it's very related to the rock type and the differences in the lithology along the Changjiang basin. The Changjiang River is highly sensitive to human activities, but there should be like further research, mostly in the anthropic deposition, especially in the Changjiang River, and all the changes that have been happening in China with the land degradation, especially in the last few years, and the areas related to the tributaries. The Three Gorges Dam clearly influences the sedimentation and promotes the particulate absorption by organic particulate. And the TDS and dissolved solutes suggest there is a limited but increasing with the years anthropic pollution. So the correlation, as mentioned, the pH decreases and the copper increases. The temperature has a positive correlation, the salinity too, and the TOC that also has, especially in the particular stage, a very high correlation. So in conclusion, there is a very strong suggestion that the heavy copper isotope signatures in this river are mainly because of chemical weathering. But it also the increase in wastewater treatment and changes in the land cover are affecting this increase or this heavy copper isotopes. So as it can see in the picture, the mass balance, it's not fully defined for copper, but there is a particular consideration that maybe copper is also related to like a different, the fractionation of copper can vary from a lot of different stages, from low temperature and also high temperature. So copper has one of the biggest variations, especially in the isotopes, that it can show like different tendencies depending on the lithology. And between the headwaters and upper reaches and the middle and lower reaches, especially because of the different weathering or chemical weathering that can be found. So thank you very much.
Thank you, Anna. Thank you very much for this interesting and very exciting talk. It was excellent to hear. It's very interesting that you are also studying copper, that and Yangtze River, and going back to Bronze Age and the fascination of people at that time with this golden metal and all the vessels that were made actually of copper. It's interesting. It would be interesting to understand where was this copper actually coming from. It's also very nice to see that Yangtze River is getting less polluted lately, right? In the past years, this is something.
Well, no, it actually like the river is not as polluted as initially was thought, but it's getting more polluted because of the changes in the land. In the land cover. But this also applies to pretty much all the rivers in the world. So it also depends, there is like not only analyzing the dissolved and the particulates, it's also required to do special analysis of the soils and the sediments to understand how much it influences. Because for example, the Changjiang has from 0.8 to 1% more copper, like the higher copper isotopes than the rest of the world. So like the average of the rivers. And it has a third of the flow of the Amazons. So this kind of questions was easy to assume that it was because of pollution. But our analysis shows that it's more related to the lithology. So we are trying to understand a little bit more of how the copper or some of the trace metal cycling works and how it gets positioned, and the mass balance in the ocean can be calculated. Because so far there is so many questions in the case of copper, because it's really hard to understand, especially because this is a biomarker. So copper is very related to the presence of bacteria or organic ligands. And yeah, it's a question in process.
Yeah, sure. And there are also so many ways that it can get into the river through anthropogenic pollution, right? Mm-hmm. Agriculture, industrial, urban usage, like traffic. Okay, Danny, would you like to ask the question?
Yeah, I have several, but maybe picking up on introducing copper into system. How about anti-fouling paint from shipping? So there's a lot of shipping on the river, and at least in the past, it used to be very common to use copper as an anti-fouling agent. I know it's regulated in some places. I have no idea what's the case in China. Could this be also a contributor to copper influx into the river?
Probably, but for this case is like to understand a little bit more about the trace metals, like I mentioned. If we try to compare or take in some basis, is in the headwaters, there is no ships, there is no deposits, and it has like a very high level of copper concentration in comparison. So there is still, like in the case of the Changjiang River, there is evidence until 10,000 years ago that there was some ores that they were being smelt. And especially one of the areas that we collect the samples, and the temporal samples were collected also from a little bit upper the Tongji area that is in the middle lower reaches. and they have like this huge copper industry there. So there is a certain level of variation, but it's not so significant. And from that copper, there's a few studies that actually try to describe how much of the tailings get into the river, and it's not so common. Like for that copper to be completely dissolved, it takes a long time, right? So this certain analysis, mostly copper gets absorbed by organics even before they reach to the river. And the highest, the oxidation of this weathering, it can be found mostly from hydrothermals or ores leaching, like water that comes to the ores and leaches into the groundwaters to the river. But the amount of vessels that you can find in the Changjiang, yes, is huge, but it's not so relevant when you compare with all the samples. So it's mostly the discharge and the oscillation, the flow, that you can see like how this is actually making a big variation. Even with the in relation to agriculture, there are analyses that says like some of those nitrates doesn't really affect that much the concentration of copper in rivers, especially one as large as the Changjiang. But these are analyses that are meant to focus a bit more, to actually proceed to get better conclusions, because half of this is still suggestions in X locations or certain rivers. So there is not so much research on copper isotopes in the Changjiang so far, or even copper isotope analysis in rivers worldwide. It's something that it's on development.
And you are very much contributing to that. Hans-Peter.
Yeah, I was wondering also, because of land use and agriculture, so many pesticides contain copper. I think you could analyze the copper isotopes from the pesticides. Do you actually see them in the river?
You don't see it in the river. You see certain level of pollution, especially when we were collecting the samples near the estuary. So there is a big amount of like metal concentration, especially in the bay. But this is also the pollution that you see, it's mainly caused by like people living in the river. They don't really respect the river as the government wanted to. And there is a lot of fuel that you can see near the vessels, especially in the areas near the estuary. However, for both, in the case of pesticides, there was one research in 2015 that reached to the conclusion that those copper was not so much influenced by the copper concentration. It could be affected a little bit, but not so much the isotopes, because to get a fractionation of the isotopes, you require a certain level of certain conditions that it's not going to be done by the pesticides, or unless you have an increase in certain nitrates and bacteria that produce the fractionation, but it's not going to be so much influenced.
Ms. Peter, do you have a follow-up? Danny.
No, thank you.
Okay, I have one last question, then I have to unfortunately run. So if I got the concentrations of copper from your graphs, they are not still reaching the toxic levels, correct?
Mm-hmm.
Or on the border? So I mean, my question related to this, can you correlate changes in biodiversity in relation to changes in copper concentrations in the whole catchment area or in the river itself? Do you see something that could be related to copper, or that's still too low to correlate? If you look into that, yeah.
Soil concentration of copper is always too low. So you can see this variation, especially in the particulate, because it gets, like I was mentioned, like especially the particulate that has like a strong correlation with organics. So in the particulates, they get into either organic ligands absorption by the bacteria. So this creates like the fluctuation between the different stable isotopes of copper, that it's 65 and 63. So for concentration, it can like vary, but to have a fractionation of the copper, it requires like we're not like really working with organics or biogeochemicals. So we do the analysis mostly focus on geochemistry or the geological input, not so much on the effects that it has in the plants. I know, for example, if you analyze soil, the first, the surface or the first 15 centimeters of the soil, it's going to have a big copper depletion. That is because the grass absorbs the copper. So the lower you go, you can analyze how deep in the soil it's the concentration until it arrives to, well, it reaches to the point that there is no copper. If you try to pollute copper in the soil to analyze this variation, right? Especially in the tailings. But mostly the organics, yes, they're going to absorb the copper, but it's not so much that I'm aware or that I worked in this particular field, but I have seen like this variation in soils at least.
Okay, thank you very much.
You're welcome.
Thank you again for this excellent presentation and great discussions that we had, both to you, Anna, and to Qing. I would also like to thank to everyone who was today here, and also to all of you who are watching us through YouTube channel. Also to the whole Early Career Committee, especially to the subcommittee that is in charge of organizing the Amplifying Voices webinar series, and many, many thanks to our communications team of ASLO that is led by Brittany Schiller. Thank you all so much, and I will just post here a slide again with a QR code on how to, if you're interested in giving a presentation as part of the ASLO Amplifying Voices series, then you can follow the QR code. Just a moment. And this is coming. I hope you can all see.
Thank you, Mina and Brittany, for organizing.
It was great having you as speakers, Qing and Anna. Thank you very much.